number 1. Number 1 says, what is 1789 plus 94 plus 105 plus 6? Let's fill these in. We'll write our numbers from right to left to make sure that they are in the proper columns. Each digit is in the proper column. So we have 9, 8, 7, 1. We have 4, we have 9 for 94, we have 5, 0, 1, and we have 6. We are going to be adding, so we put our addition sign here, and then we start adding. So we have 6 and 5 being 11, 11 and 4 being 15, 15 and 9 being 24. We'll put down our 4 and we will carry 2. Let's start from the top. We have 2 and 8 being 10, 10 and 9 being 19. So we'll put down our 9 and carry 1. Starting from the top again, we have 1 and 7 being 8 and 1 being 9. And we have 1 here with nothing else, so we bring it back down. So our answer would be 1994. So our answer for number 1 is A. Number 1, our answer is A. Number 2. Number 2 says, which represents $60,002? Let's put in what we have here in the grid. So writing from right to left, we have our decimal point here. We have 0, 0, 2 ones, no tens, 600. So this would be $602. So that's not $60,002. So it's not A. Then continuing with B, we have 0, 0, decimal point. We have 2, 0, 0, 6. Reading again now, we have $6,002. No sense. So this is not the same as $60,002. For C, we have 0, 0, or decimal point, 2, 0, 0, 0, 6. Now we have a set of 10,000. 6 tens would make 60. So this would be $60,002, 0 cents. This looks like our answer. However, we must look at all the options, and we have another one. We have 0, 0, 2, 0, 0, 0, 0, and 6 would be in the next column, which would be 100,000. So we'd have $600,002, right? And they didn't ask us for 600,000, they asked us to represent $60,002. So our answer for number 2 is C. So for number 2, our answer is C. Number 3. Number 3 says, which will give the value of the underlined digit in 1948, and the 9 is underlined. So let's fill this into our place value chart or grid, writing our numbers from right to left. So 8 first, then 4, then 9, and 1. The 9 is underlined, so it would be 1 times 1000, 9 times 100. Okay, and that is option C. So for number 3, our answer is C. number 4. Number 4 says, how many odd numbers are between 50 and 64? So here we've listed the numbers 50 to 64. So it says between. So we can't use 50 and we can't use 64. The numbers need to fall between those two numbers. So an odd number is a number that when we divide it by 2, it will leave a remainder. Okay, it's not exactly divisible by 2. So our odd numbers would be 51. If we divide 51 by 2, we are going to end up with a remainder. 53 is also odd. 55 is odd. 57 is odd. 59 is odd. 61 is odd, and 63. So we have 1, 2, 3, 4, 5, 6, and 7. So we have 7 odd numbers between 50 and 64. So our answer for number 4 would be C. For number 4, our answer is C. Number 5. Number 5 says, which digit in 1529 has the greatest value? So, writing from right to left, let's put the number in. We have 9, 2, 5, and 1. Okay. Now, the 9 would be 9 ones, 2 tens, 5 hundreds, 1,000. And of course, the 1,001 has the greatest value, because 1,000, one group of 1,000 is larger than hundreds, 500s, or 20, or 9. So our answer for number 5 is going to be A. Our answer is A, because the 1 here represents 1,000, which is more than 500, more than 20, and more than 9. So again, number 5, our answer is A. Number 6. Number 6 says, what is 3 minus 0.976? So our decimal point will go in this section. So we have 3, and that would be 3 ones. Then we have a decimal, so we have 0 what? 0.9 in the tens place, 7 hundredths, and 6 thousandths. So now we need to put in some placeholders and our decimal to maintain decimal under decimal and column under column. So we put our operation sign, which is subtraction, there. And now we're going to say 6 from 0. We can't. We need to go all the way over to the ones column, and we will take what? 1 from it, leaving 2. We put 1 here, and we'll take from it again so that we can move to the next column, and we'll repeat that until we get the 1 here. So now we say 6 from 10 will leave 4, 7 from 9 will leave 2, 9 from 9 will leave 0, decimal point under decimal point, and we have 0 from 2 leaving 2. My answer is 2.024, and that would be A. So for number 6, our answer is A. Number 7, they asked us to fill in the missing number. Between 2 and 5, we have 2, and we have 3 more things. Between 5 and 11, we have 5 more and 1. So we have 5 and 5 and 1. Between 11 and 23, we have 11 and 11, 22 plus 1. Okay, let's see if this works out. Between here, it appears that each time they move up, they are doubling the number, and adding 1. So 2 plus 2 plus 1 gives me 5. Then 11 plus 11 plus 1 would give me 23. Okay, so what would come here should be what? 23 plus 23 plus 1, which would be 23 and 23, 46 and 1, 47. Now if this is correct, it would mean that 47 plus 47 plus 1 should give me 95. So 47 plus 47 plus 1 should give me 95. Now 47 and 47, 7 2 is 14, put down the 4, carry 1, and 4 and 4, 8 and 1, 9. Then you add 1 to that and you get 95. So our answer is correct. And for 47 it would be C. Okay, this takes some amount of time to solve for some people. Some people see it quite easily, some people have to look at it over and over again. But what they're doing here, they are doubling the number, they add the number to itself and then add 1. Okay, these type of problems just take practice. Okay, number 8 asks us to put 1,201,211 in words. So we would have 1,201,211. So that would be putting it in words. So the one that best describes what we have here and correctly describes it would be C, option C, as 1,201,211. So for number 8, our answer is C. For number 8, our answer is C. Number 9. Number 9 says, which set has only improper fractions? Now a proper fraction, so proper fractions are fractions where the numerator is smaller than the denominator. That's a proper fraction. An improper fraction is where the numerator is larger than the denominator. So if we look now, we look at A, and it says only improper fractions. It can't be A, because A has a proper fraction being 3/4. So for A, 3/4 is proper, and they want only improper. So the 3/4 would make A wrong. Let's look at B. B has 3/4 again, making it a proper, that's a proper fraction. So B can't be right because it has 3/4 in there being proper. It has 5/7 as proper, 2/5 as proper, and 7/10 as proper. So all of B would be proper fractions. Let's look at C. C has 2/3 proper and 3/2 as improper, 3/4 proper, and 3/5 proper. So it's not C. So C is also out of it, right? They have fractions in there that are proper, and we want only the improper. So now we have here, number 9, last one now, D, being 5 over 3, yes, that's improper. Why? Because the numerator is larger than the denominator. Okay, we have 3 over 2. This is also improper because the numerator is larger than the denominator. We have 7 over 5. This is also improper because the numerator is larger than the denominator. And finally, we have 9 over 8. Again, improper because the numerator 9 is larger than the denominator 8. So this set here in D is the set which has only improper fractions. Other fractions, improper fractions are present in some of the others, but only is the word that we're looking for. So for number 9, our answer is D. Number 10. Number 10 wants us to add 2,608, 98, and 369. So let's fill these in, writing from right to left. We have 8062 with 89, column under column, 963. We are adding, so let's go. 9 and 8 would make 17. 17 and 8 would make 25. So I can put my 25 outside here. I would set down my 5 and carry my 2. 9 and 6 would make 15. 15 and 2 would make 17. I set down my 7 and carry 1. 3 and 6 would make 9. 9 and 1 would make 10. I can set down my 0 and carry 1. And 2 plus 1 is 3. My answer being what? 3,075. 3,075. So for number 10, my answer is D. Number 10, D. Number 11. Number 11 says, which numeral names 9 hundredths? So let's fill in what we have here. We have a decimal point here, and let's fill it in as best as possible. Number 1, we have one place of decimal, 009. For B, we have 0.9. For C, we have 0.09, and for D, we have 0.009. Let's fill in this with some placeholders so we have a better idea where we are. Okay, now we are looking for 9 in the what? Hundredths column. So here we have the tens, hundreds, thousands, and this A, B, C, and D. Okay, my answer is going to be C. My answer is C, because in the hundredths column, 9 in the hundredths column is represented by C. So for number 11, my answer is C. Number 12. Number 12 says multiply 706 by 7. So I set it out, and now I will use the 7 to multiply 6. So 7 sixes would be 42. Put on my 2, carry 4. 7 times 0 is 0. Carry back down the 4 that I have there. And 7 sevens will be 49. So my answer will be 4,942. 4,942. So for number 12, my answer is B. Number 13, what is 927 minus 531? So I will now say 1 from 7 will leave me with 6. 3 from 2 can't work, so I'll need to take 1 from the 9, leaving 8. That set of 10 will now make will go over into the tens column, and with the 2 that's there, this will make 12. So 3 from 12 will leave me with 9, my 9 here, and 5 from 8 will leave me with 3. My answer should be 396, which is D. So number 13, my answer is 396, D. Number 14 asks, what is 253.91 minus 148.89? 9 from 1 can't work, so I'll take 1 from the 9, leaving 8. That one set of 10, and the 1 here makes 11. So 9 from 11 would leave 2, and 8 from 8 would leave 0, nothing. I would keep my decimal point here, decimal on a decimal. Continuing now, we have in the ones column, because this would have been decimal. So in the ones column, I have 8 things to take from 3. That can't work. I need to take a set of 10 from the 5, leaving 4, and this set of 10 with the 3 now becomes 13. So 8 from 13 will leave 5, and 4 from 4 in the tens column now. 4 from 4 will leave 0, and 1 from 2 will leave 1. So my answer should be 105.02, and that will be D. So for number 14, my answer is D. Number 15 says, what is the value of the 7 in 47,321? And to work this out quickly, I have placed it in the place value grid or place value chart, and we have our ones, 1 being there, our tens, 2 being there, our hundreds, 300, and 7,000s. So our answer for number 15 would be C. Our answer would be C, as in 7,000s. Number 16. Number 16 says, which set of numbers is ordered from smallest to greatest? That's ascending order. All of the options have the same set of numbers. They have 61. They have 61. Then we have 161. We have 116, and we have 611. So let's determine which one is the smallest. Okay, let's go from largest first. Here we have in the hundreds column, we have 6, and the other 2 have 1. So we know that 611 is the largest number. All right, then now we have 2 numbers that have 1 in the hundreds column. We now determine which one is larger by what happens in the tens column for those 2 numbers. And 6 comes before 1, so 161 would come next. Then of the 2 numbers that are left, which would be 116 and 61, because this has a digit in the hundreds column, 116 would come before 61. Now this here is the smallest number. going up to the largest. So the answer we're looking for should have 61, then 116, then 161, and finally 611. So these two are out of it, D and C, because both of those end with 116 and 161. We need an answer that ends with 611. So it has to be A or B. So let's go now. 61 in the first column, yes. Then 116, this is 161. So our answer is B. 61, 116, 161, and then 611. So for number 16, my answer is B. Number 17 says, which of the following has the least value? Okay, so let's fill in these. For A, we have 3 ones and 6 tens, or 63. Then we have for B, no ones but 6 tens, that's 60. We have 4 ones and 6 tens, that's 64. And then we have 9 ones and 6 tens for 69D. Now all of them have the same value in the tens column, so we would now have to go to the ones column to see which one would have the least value, and automatically we know it would be B having the least value, because 0 is lower than 9, 4, and 3. So 60 is the least in value of all these 4 numbers. Okay, number 18 says, which will give a multiple of 8? Now we need to understand what a multiple is. Now a multiple is when we have a factor, we multiply it by another factor, and the product is going to be a multiple of the factors multiplied. Okay, so if we have, for example, 8, the multiples of 8 would be 8 times 1, giving me 8. So 8 is a multiple of 8. And 8 times 2 would give me what? 16. So 16 is a multiple of 8. 8 times 3 would give me what? 24. So 24 is a multiple of 8. And 8 times 4 would give me 32. So 32 is also a multiple of 8. That's how multiples behave. Now let us look at what they have. 8 minus 8 would be 0. Is 0 a multiple of 8? No. Next we have 8 times 0. Any number multiplied by 0 is going to be equal to 0. So is 0 a multiple of 8? Again, no. Next we have 8 divided by 8. 8 divided by 8 would give me 1. Is 1 a multiple? Here are the multiples. First 4. Is 1 a multiple of 8? No. Then we have 8 plus 8 is equal to 8, and 8 would make 16. Is 16 a multiple of 8? Yes it is, because 8 twos will give me 16. So D, or answer for 18, D best shows the multiple of 8 expressed in the options. There are some students who were able to pick up that number 19 and number 33 are the same thing. Okay, however, we will go through it nonetheless. Which will give the value of the 2 in 52,561? So writing from right to left, column under column, we have 1, 6, 5, 52,561. So writing this out, it would be 5 times what? 10,000. Okay, and this would give us 50,000, right? Plus 2 times 1,000, being the 2,000, plus 5 times 100, plus 6 times 10, plus 1 times 1. Now in the column for the thousands, we would have 2 times 1,000, and that would give you the value that is there. So our answer in this case for number 19, as with number 33, our answer is going to be B. Number 20. What is 9/10 plus 3/100 plus 4 thousandths? So we'll have to revisit our place value grid to include the decimal units. So let's look at them now. We have our decimal point, and we have our decimal point here. Let's put it in. We have to the right of the decimal point, we have tenths, which is really 1 part out of 10. We have hundredths, which is 1 part out of 100. Let's fix our 10. So 1 part out of 10 here, 1 part out of 100, and for thousands it would be 1 out of 1,000. Okay, we have our ones. These are whole numbers now to the left. We have ones, tens, hundreds, thousands, and so on. So let's look at the first one. We have 9/10. So we're going to be putting in our 9 under the tenths section. Okay, next we have 3/100. So under the hundredths we have 3. So we put a placeholder here. Let me change colors for the placeholders. So we will put a placeholder here and a placeholder here. So we have 3/100. And finally we have 4 thousandths. So in the thousands column we should have 4, and we put placeholders here, 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 and here. They say that we're going to be adding, so let's maintain our decimals. So we use 0 to show that we have no whole numbers. Okay, so let's add 4 and 0, 4, 3, and we have 9. So our answer should be 0.934. 0.934, and this is shown in answer D. So for number 20, our answer is D. Please remember, we must show our if we were working it out for regular classwork, we'd have to show our operation. We'd have to make sure that things are represented column under column and decimal point under decimal point. Is that clear? Okay, good. Number 21. What is 10 times 10 times 10? And we could just bracket off these two, and we said 10 times 10 would be 100, and 100 times 10, or 10 groups of 100, would give us 1,000. So our answer for 21 is A. Our answer for 21 is A. Number 22. Which of these shows 40 as a product of its primes? Okay, so remember what prime numbers are. They only have factors being 1 and itself. Okay, so let's look at 40. Let's use the factor tree approach. So we have 40. What two things could give us 40? 2 times 20 could give us 40. This is already a prime number, so we won't go any further with this. What two things could give us 20? Two factors could give us 20. We could break this into 2 and 10. 2 is already prime, so we won't work on that side anymore. We have 10. What two things could give us 10? We could use 2 and 5. Okay, so 2 is also prime and 5 is also prime. So let us list the prime factors of 40 now. They would be what? 2 here, 2 times 2 times 5. We see that this matches what we have for D, so our answer is D. So 2 times 2 would be 4, 4 times 2 would be 8, and 8 times 5, 8 5s 40. So we prove that the answer D is correct. We could also look at it using the ladder approach. We have 40 and we start with our lowest prime, 2. 2 could go into 40 20 times. 2 could go into 20 10 times. 2 could go into 10 5 times, and 5 could go into 5, of course, 1 time. So what are the things that the prime numbers I'd use outside? I'd use 2 times 2 times 2 times 5. So whichever way you want to work it out, we should get our answer being D. So for number 22, our answer is D. Number 23 says, what is 2346 in expanded form? So we write our number in our place value grid here, writing from right to left so that we observe the columns. We have 6 in the units column, 4 in the tens column, 3 in the hundreds column, and 2 in the thousands column. So we could set that out like this. We are saying that we have 2 times or 2 groups of thousands, we have 3 groups of 100, 4 groups of 10, and 6 groups of ones. Writing that out, we could have 2000 plus what? 300 plus 4 tens 40, and 6 ones 6. And this is shown in B. So our answer for number 23 is B. Number 24, it says which statement is true, and we have some statements here that deal with exponent. Let's just review quickly exponential form. In exponential form, we have what we call the base and we have the exponent. The base, which is this number, is repeated in multiplication the number of times indicated by a smaller digit above it to the right. So 10 square is 10 times 10. So it appears, the base appears 2 times in this multiplication to give us 100. So 10 to the third, or 10 cubed, is 10 times 10 times 10. Okay, so it appears how many times? The base appears 3 times, and this answer of course is 1000. Okay, so let's make some space and we will write in our chart that we use in class, and we say 10 to the 0 power is really 1 multiplied by nothing, okay, because there's no base present. 10 to the first is equal to 1 times 10, which is 10. Okay, 10 to the second is equal to 1 times what? 10 times 10. 10 to the third is equal to what? 1 times 10 times 10 times 10, which is 1000. Alright, so let's look and see if we have these statements being, which one is true. 10 to the first, sorry, 5 to the first. Is 5 to the first 1 plus 5? No, so that's incorrect. Is 5 to the 0 power 0 plus 5? No. Is 4 to the 0 4 times 0? No, that's not correct. Is 4 to the first, is it really 4 times 1? Yes, it is, because we would have what? 4 present, 1 multiplied by 4. Okay? Or 4, as they have it, 4 times 1. Remember that whichever way I put my factors in multiplication here, my answer would be the same. Alright? The chart that we use in class, we start with 1. The chart that they are using here, they end with 1. So it is 4 times whatever we'd be going up by. Okay? So it is the same. So our answer in this case is D. Our answer is D, as in 4 to the first. Number 25. Number 25 says 3 cows were sold for $17,000. If 2 cows were sold for $11,000, which will give the selling price of the third cow? So this is simply asking us to identify the operation that will give us the answer that we need. And we are given the final price. We know what 2 cows cost. So all we need to do is to subtract. We need to take what we know from the overall selling price, and we will get the cost of the third cow. So our answer in this case is B. So it would be $17,000 minus the $11,000, which is the cost of the 2 cows, and then we get the cost of the third cow. So for number 25, our answer is B. Number 26. Number 26 asks us to add 14 1/4 and 6 7/8. So let's go through now. Let's deal with our whole numbers. We have 14 plus 6, which is equal to 20. So it is 20 plus whatever 1/4 plus 7/8 is. Okay, so let's find a common factor, a common denominator rather, for 4 and 8. We can use 8, and 4 could go into 8 2 times. 2 ones would be 2, plus 8 into 8 1 time. 1 times 7 7. So remember 20. When we have this section added, we are going to get 9 eighths. So we have 20 plus 9 eighths. Let us change this improper fraction to a mixed number. 8 into 9 would go 1 time and 1 over 8 plus, or 20. So 20 as whole number plus 1 as whole number would give us 21, and our fraction 1/8. Okay, so again, 14 and 1/4 plus 6 7/8. I'm going to add my whole numbers. I get 20. So my answer should be 20 plus whatever I get when I add the fractional part of the problem, which is 1/4 and 7/8. I find the LCM, or the lowest common denominator, for 4 and 8, which is 8. I say 4 into 8 goes 2 times. I use that 2 and multiply the numerator 2 ones, and I get 2, plus 8 into 8 1 time. I use that 1 and I multiply the numerator 1 times 7, or 7 ones will give me 7. I add both of those. 2 and 7 would give me 9 over 8. So it is 20 plus 9 over 8, as shown here. 20 and 9 over 8. Then I convert my improper fraction here to a mixed number. I say 8 into 9 would go one whole time with one remainder over 8. So now I add these together. 20 and 1 whole would be 21 plus my fractional component 1/8. My answer is 21 and 1/8. So that would be D. My answer is D. Number 27. Number 27 asks us, what is the HCF, or the highest common factor, of 18, 36, and 72? We're going to use a little prime factorization here, and we're going to establish that. When we're doing using prime factorization to find the HCF, we're going to look for factors that can go into all of the numbers at once. When we're doing the LCM, we are not so concerned with the number going into all of the numbers. We just want them to be able to go into the numbers, and then we move on until we get one at the end. Okay, but for the common factor, it must go into all of them. So let's go now. 2, starting with the smallest prime factor, 2 could go into all three numbers, right? So 2 could go into 18 9 times, and 2 could go into 36 18 times, and 2 could go into 72 36 times. Okay, we could use 3. 3 could go into 9 3 times, 3 could go into 18 6 times, 3 could go into 36 12 times. We could use 3 again, because 3 could go into all of these numbers. 3 could go into 3 1 time, 3 could go into 6 2 times, and 3 could go into 12 4 times. However, we have to stop here because we cannot find a number now that could go into 1 2 and 4, all of these without leaving remainder, because even if we were to use 2 can't go into 1 like that. 2 could go into 2 here, and 2 could go into 4, but it can't go into all of these numbers here. So we now circle what we have here, and we multiply these in order to get our highest common factor. What we have is 2 times 3 times 3, or we could rewrite it and say we have 2 times 3 squared, which is 2 times 9. 2 times 9 is 18. So our highest common factor is 18. Based on our responses, for 27, our answer is D. Number 28. Which of the following has the same value as 0.25? And we have 25 divided by 1. Now 25 divided by 1 is going to give us 25. Okay, anything divided by 1 will give you the same result. Next we have 25 divided by 1000. So our decimal point would be there. We're dividing, so we're going to be moving digits to the right of the decimal point. How many digits do we need to move? Based on the number of zeros, 1 2 3, we have 2 here, so we'll put another 0 there, right? And we would move all of these over they jump over the decimal point, right? Decimal point doesn't move, but the digits move over, and we'll put a 0 to hold the place in front. So we have 0.025. So that would be B. So far A does not match, so A is wrong, and B does not match, so B is wrong. Let's see what C says. C would be 2.5 divided by 10. Okay, so we're going to move one digit over the decimal point to the right. So let's go now. We have this digit here, the 2. We're going to move it over the decimal point and put it in front of the 5. So now we're going to hold the place with a 0. 0.25. This matches what we have here, but we have to make sure we go through all our options. So let's go through D. We have 2.5 divided by 100. So we're going to be moving 2 digits over the decimal point to the right. We only have 1, so we need to put another one. So we're going to be moving these 2, and we're going to be moving them in front of the 5. So we're going to end up with what? Put a placeholder, 0.025. Okay, now the only one that matches what we have been asked to find is C. So our answer for number 28 is C. Question 29 asks, which word best describes the members of set A? And in set A we have 4, 6, 8, 9, and 10. Is the set of numbers there odd, even, prime, or composite? Let's deal with odd numbers first. What are odd numbers? An odd number is one that when we divide the number by 2, we'll have a remainder of 1. So here we go. 2 is even, 6 is even, 8 is even, 10 is even. The only odd number we have would be 9. So 9 is odd. Let's examine even numbers now. So we have established that the set A could not be speaking to odd numbers, so this is out. Let's look at B, even numbers. 2, when a number can be divided by 2, when it is exactly divisible by 2, then it's even. We using the steps we had established in finding that 9 was odd, we know that 4, 6, 8, and 10 are even, and 9 is odd. Therefore, it could not be a set of purely even numbers. Okay, so it could not be even numbers. Let's look at C, prime numbers. Prime numbers are numbers that have only 2 factors, 1 and itself. What are the factors of 4? So we would list the factors of 4 being 1, 4, and 2. A number with more than 2 factors is said to be composite. So 4 is a composite number. So already we have established that it could not be C, because the numbers, one number here already, 4, is a composite number. Let's check another one, say 6. 6 factors of 6 are 1, put 6 over here, and 2 times 3. So the factors of 6 would be 1, 2, 3, and 6. Again, a composite number. So we look now at D, which is the only one left. So our answer should be D, and we can check this with all of them. We have established that 4 and 6 are composite numbers. Let's look at 8. 1, 8. Other factors being 2 and 4. So again, we have more than 2 factors. Let's look at 9. 1, 9, and 3. Okay, what about 10? We have 1, 10, 2, and 5. So the set A, being 4, 6, 8, 9, and 10, is a set of composite numbers, and our answer in this case is D. Number 30 asks, how many things make a score? And a score is made up of 20 things. A score is made up of 20 things, and our answer would be C. Number 31 asks for the pair of prime numbers listed below. Now, a prime number is a number which only has two factors, being 1 and itself. So we have prime numbers, we also have composite numbers. A composite number has more than two factors. Okay, so let's examine these numbers. So is 29 prime? Is 29 prime? What are the factors of 29? 29, the only things we know can go into 29 are 1 and 29. Okay, alright, so we know that the answer must have 29 in it. Okay, 21, is 21 prime? What are the factors of 21? We have 1, we have 21, we have 3, and we have 7. 1 times 21 will give you 21. 21 times 1 will give you 21. 3 times 7 will give you 21, or 7 times 3 give you 21. So this is composite, so we know automatically that this answer here, C, cannot be right. Let's look at 15. We're going to examine 15 now. 15, what are the factors of 15? 1, 15, 3, and 5. So this also is a composite number, so we can't use 15, so that is also wrong. Now, looking at the items that are left, we have only these two items left, being 29 and 33, and 29 and 37. So we already established that 29 is prime, so now we're going to be looking at 33 and 37 to see which is prime. Let's deal with 33. What are the factors of 33? We have 1, we have 33, we have 3 can go into 33 11 times. So we already established now that it cannot be A, because 33 is not a prime number, it's composite. So our answer is going to be B, 29 and 37. Number 32. Number 32 reads like this: which operation will result in the difference between 4/5 and 3/8? And it's simply asking you, the word difference goes with what sign? So the word difference goes with the minus sign. Okay, minus sign. Now that would be B. Our answer here is B. If we use the word plus, together, add, it's for addition. We use minus, difference, subtract, less, it's the subtraction operation with the minus sign. We use times, multiply, product, those are associated with the multiplication sign. We use share, divide, into, those are associated with the division sign. So this question is simply asking you to identify what is the operation that would show difference, and that operational sign, the sign for subtraction, is a minus sign here. Answer B. Number 33 says, which will give the value of 2 in 52,561? To better understand this, let's fill in our numbers in our place value chart. So we start going from right to left: 1, 6, 5, 2, 5. So we have 5 sets of 10,000, 2 sets of 1,000, 5 sets of 100, 10 sets of 10, 6 sets of 10, and 1 unit. So the number that we are focusing on here is 2, and it's in the 1,000 column. So this would be 10,000, this would be 1,000, this is 100, this is 10, and this is 1. So our number would be in expanded form 5 times 10,000 plus 2 times 1,000 plus 5 times 100 plus 6 times 10 plus 1 times 1. Okay, so to get the value we want, we're going to be looking here, which is 2 times 1000. So our answer is B. Our answer is B. 33, answer B. 2 times 1000. Number 34 asks us to complete the sequence by saying which number would come next. Let's identify the difference between these numbers. We have 16 and 25. Our difference here is 9. 25 and 36, our difference here is 11. And 36 and 49, our difference here is 13. We notice that each time they're moving up, they go up by 2, because 9 and 2 would make 11, 11 and 2 would make 13. So the next number would be going up by 15. So whatever this is, plus 15, plus 15 should give us our answer. So it would be 49 and 15. This would be 4 and 4 and 1, 5 and 1, 6. So our answer should be 64. Okay, to go over that, I looked for the difference between 16 and 25, which was 9. I looked for the difference between 25 and 36, which was 11. I then looked for the difference between 36 and 49, which is 13. I observe that the numbers here, they increase each time by 2. So if I am here at 13, I need to increase by 2 to get 15. So whatever this number is, plus 15 will give me the missing number. So that's how I ended up with 64. And 64 is C. For number 35, we're given a sequence here and we're supposed to complete it. Now they have shapes and numbers. So let's figure out the shapes that would complete the sequence first. We start off with a triangle, a box, triangle, triangle, box, something, then we end up with triangle, number, box. Now based on what we see, whenever we end with a certain shape, we start with the shape. So for the missing section, we end with a square, so we're going to be starting with a square. And then if we end with the triangle, we're going to start with the triangle. So we know that our answer must start with a square and end with a triangle. All right, so that will keep it true, because here we end with a square and start with a square. We end with a triangle and start with a triangle. So we end with a square, we must also start with a square. Let's look at the numbers now. The numbers start here, 2, then they go 4, they go 6, then something, then 10. Now simple counting, 2, 4, 6, 8, here 10. So our answer should be box or square, 8, triangle, and that would be D. That would be D, square, 8, triangle. Number 36 says, what is 86 cents rounded to the nearest dollar? Okay, now the nearest dollar, which is a whole, would be here in our units column. We have tenths and we have hundredths here. Now whenever we're rounding, identify the column that we want to round to. Look to the digit. This is our column of focus. Look to the digit that is to the right of that. If that digit is 5 or more, then we are going to be rounding up. If it's 4 or less, we're going to be rounding down. This falls into the rounding up group because it is 5 or more. Okay, so we're going to add 1 to our column of focus. So there's nothing there, so we put 1, and then we put 0 for the rest. So again, we look at our column of focus, we look at the digit that is to the right of that. If it is 5 and more, we're going to round up and add 1 to the digit, 1 to the column of focus. And in this case, 86 rounded to the nearest dollar would be $1. And our answer here is going to be D. Number 37 says, what is 7,506 written in exponential form? So let's have 7,506 written in expanded notation. This would be 7 multiplied by 1,000 plus 5 multiplied by 100 plus 0 multiplied by 10 plus 6 multiplied by 1. Let's bracket these off so we can see them more clearly. And now we're going to go to expanded from expanded form to exponential form. This needs to be rewritten now as what? 7 times what's 1,000 in exponential form? It would be 10 to the third, or 10 cube, plus 5 times what's 100? 10 square, plus 0 times 10 to the first, plus 6 times 10 to the 0 power. So our answer, what we're looking for is this. So we're looking for, in our options, 7 times 10 to the third plus 5 times 10 square plus 0 times 10 to the first plus 6 times 10 to the 0 power. The answer that best describes what we have is D. The answer that best describes what we have is D. As you would notice in the answers, they only have 3 levels here, because really there's no 10, because 0 times anything is going to give you 0. So it would be 506. So they have as their answer 7 times 10 to the third plus 5 times 10 square plus, they have nothing here, plus 6 times 10 to the 0 power. So in doing it this way, you get a better understanding of everything that is happening. Alright, but for the answer that's there, we'd have to select D and understand that this area here is simply left out. So our answer is D. Number 38. Number 38 wants to find out what is MCMXL VI, these Roman numerals converted to our regular numbers. The M here would represent 1,000, so we have 1,000 for the M. The CM would be 1,000 less 100, so this would be 900, The XL here would be 50 less 10, so that is 40, and the VI here would be 5 and 1 being 6. So if we were to put all of this together, we would get 1946, okay, which would be 1946. All right. So in answer to our question, MCMXLVI represents the year a church was built. What year was the church what year was that? Our answer would be C, as in 1946. Number 39. Number 39 asks us to find the reciprocal of 5 1/4. One quick way of explaining what the reciprocal is: the reciprocal is a number that when multiplied by 5 1/4 will give us a product of 1. Okay, so at the end we can test to see if that is so. So another way of expressing the reciprocal is that we're going to find the multiplicative inverse of 5 1/4. Let's change 5 1/4 from this mixed number to an improper fraction. So we would multiply the denominator by the whole number and add the numerator. So 5 times 4 would be 20, 20 and 1 would be 21 over 4. Okay, so 21 over 4, the multiplicative inverse for 21 over 4 would be 4 over 21. Students like to say they turn the number upside down, they flip the number. If we were to find the product, which means to multiply, and multiply across as best as possible, we could reduce, cancel, and we cancel diagonally and vertically. So we could cancel this way, okay, or this way. Now 21 into 21 would go one time, and 21 into 21 one time, 4 into 4 one time, and 4 into 4 one time. We multiply across now, numerator by numerator, 1 times 1 1, and denominator by denominator, 1 times 1 1. So we end up with 1 over 1, which is simply saying how many times can 1 go into 1, which is 1. So this holds true to our rule, which says that the number, when multiplied by its reciprocal, will result in a product of 1. So 4 over 21 is the reciprocal for 5 1/4, and that answer is B. Number 40 wants us to look at the sets of fractions that are there and arrange them in descending order. All of them having 4 6 7 12 3/4 and a half, but they're in different places. Now, since we know that these fractions are common to all, let's see if we can find the equivalent fractions for these, and then we're able to order them. Whenever we are comparing or ordering, we have to bring them to a point where they have a common denominator. We have to make them equivalent. So 6 12 4 and 2, we could use a LCM of 12. Okay, could use an LCM of 12. Another term for LCM, in some books you'll see LCD, as in lowest common denominator. We could use prime factorization to find this out. We could say 6 12 4 and 2, and we look for something that can go into all of them. So 2 could go into all of these, yeah. 2 could go into 6 3 times, 2 could go into 12 6 times, 2 could go into 4 2 times, and 2 could go into 1. 2 could go into 2 one time. Let's go again. We could continue with 2. It can't go into 3. We write it back. It could go into 6 3 times. Yes, it could go into 2 one time, and we keep our 1. Next we go for 3. 3 could go into 3 one time. 3 could go into 3 one time. We write these back. Since we're finding the LCM, let's go and multiply everything that we have outside here. This is 1, so this would be 1 times 3, 3, 3 times 2, 6, and 6 times 2 would give us 12. So our LCM would be equal to 12. Or LCD is the same thing, so it's 12. LCM, LCD, same thing. So 6 into 12 would go 2 times, so this would be 2 times 4, 8. So 4 6 would be equal to or equivalent to 8 over 12. Okay, now 12 into 12 one time, and 1 times 7 would give me 7 over 12. So 7 over 12, the original formal fractions that we were given versus the equivalent fractions now, this would still be 7 over 12. Okay, because we are giving them all the same denominator. 4 into 12 would go 3 times. 3 times 3 would be 9. Okay, let's fill this in properly. So we're going to end up now with 9 twelfths. Okay, so 3/4 is the same as 9 twelfths. And finally, 2 into 12 would go 6 times. 6 times 1 would be 6 over 12. Alright, now it says we need to arrange them in descending order. Descending order. So we need to have the largest first, and then we move down to the smallest one. So let's now use the original, let's use our equivalent fractions that we found and arrange these so that we can, find what we should have in descending order. So which is the largest one? It would be 9 12. So this one would come first. So writing back the original fractions, 3/4 would come first. Then after 9 going down we have 8, so we would have 4/6 coming next. After 8 we have 7, so we would write 7 twelfths. Remember, we're using the original fractions that were given. And finally we would have a half. So in descending order it would be 3/4, 4/6, 7 twelfths, and a half. And if we look, our answer as stated on paper would be D. Our answer is D, number 40, D. Number 41 says 6 multiplied by 2 and 2/3. So let's put our whole number over 1 multiplied by 2 and 2/3. Let's change our mixed number to an improper fraction. We say 6 over 1 multiplied by 3 times 2 would be 6, plus 2 would be 8 over 3. And let's reduce as best as possible. We reduce diagonally and vertically. So 3 could go into 3 one time, and 3 could go into 6 2 times. Now we multiply numerator by numerator, so we would end up with 2 times 8. 2 8 would be 16 over 1 times 1, 1. So how many times could 1 go into 16? It could go in there 16 whole times. Our answer is 16. Based on the responses, our answer is B. Our answer is B. Number 42. If 3/18 plus 4/18 plus n/18 is equal to 1, what is n? Now, as long as the denominators are the same, we know that we're going to be focusing our attention on the numerators. Right? Additionally, in order to get a whole, we need to have the numerator and the denominator being the same. So if the denominator here is 18, we would need 18 parts to complete the whole. So let's look at the numerators now. We have 3, 4, and n. That should equal in 18. Let's look at this. 3 and 4 would make 7 plus n being equal to 18. Right? Let's do a little algebra. We're going to take our 7 and subtract it from the 18 and leave n on this side. So this would be 18 minus 7. So n is going to be equal to what? 7 from 18 would be 11. So our answer here is going to be 11. N is equal to 11. Now, what response is that? That would be C. Should be C. Item 43. Now, question 43 says, which will give the product of 137? And this is a simple question. It simply wants to find out if we can associate the term product with the right sign, the right operational sign. So, product is a result of multiplication. We have factor times factor will be equal to the product. Okay, so the factors here would be 100 multiplied by 37, and we would get an answer we call the product. So this is what we're looking for. We're looking for this sign because this sign is associated with multiplication. And looking at our answers, that would be B. That would be B. So as long as we hear the term product, we are looking for that multiplication sign. Number 44. Number 44 says, which term best describes this set of numbers? And the set of numbers shown is 3, 5, 7, and 9. And the options we have for answers are A, counting numbers, B, even numbers, C, odd numbers, and D, prime numbers. Let's look at our options carefully. So counting numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Even numbers are those numbers that are exactly divisible by 2, like 2, 4, 6, 8. When you divide them by 2, they do not leave a remainder. Odd numbers are numbers that when divided by 2 will leave a remainder. And prime numbers are numbers that only have 2 factors, 1 and its. So the answer that best describes what's happening here with 3, 5, 7, and 9 would be C, odd numbers. C, odd numbers. And why C? It's because if I divide 3 by 2, I'll have a remainder of 1. If I divide 5 by 2, it goes in there 2 times with a remainder of 1. If I divide 7 by 2, it goes in there 3 whole times with a remainder of 1. If I divide 9 by 2, it goes in there 4 times with a remainder of 1. So even from 3 dividing all the way through, we're going to get a remainder of 1, and that would classify it as an odd number. Okay. Number 45. After paying $478.97 for an item, the change received was $21.03. How much money or how much was the cashier given? So let's use a simple example. I go to the shop, I have $5, right? I pay $3 for a sweet. So I pay $3 for a sweet and I get back a change of $2. Now, if I had said to you before that I went to the shop and I paid $3 for a sweet and I got $2 change, how much money did I give? We automatically know that we'd have to say 3 plus 2 gives us 5, and we get the answer. Now similarly, we're going to do the same thing with this problem. It says we got the change of $21 and we paid $478.97. So what we would need to do, just like here, we would need to add. So let's add. 3 and 7 would make 10. We carry 1. And 9 and 1 would make 10. Carry 1. Let's maintain our decimal point. And we say 8 and 1, 9 and 1, 10. Carry 1. And 2 and 7, 9 and 1, 10. Carry 1. And 4 and 1 would make 5. So our answer here is $500, and that is B. $500, B. Number 46. Number 46 says we should write 349 in exponential form. Now, let's look at this now. We have 300, which is really 3 times 100, plus what? 4 times 10, plus 9 times 1, right? This is expanded notation. Let's look at this now being written in exponential form. What is 100 in exponential form? That would be 10 square, plus what is 10 in exponential form? That would be 10 to the first. And what would be ones? So it would be 10 to the 0 power. Let's put these back now. So this is 3 times 10 square, right? Plus 4 times 10 to the first, okay? Plus 9 times 10 to the 0 power. So this is what we're looking for in our answer. Do we have that there? So our answer here would be B. Our answer would be B. Number 47. Number 47 says, what are the prime factors of 36? So let's get 36 and we'll list the factors. 1, put 36 over here. 2 can go into 36 18 times. 3 could go in there 12 times. 4 could go into 36 9 times. And 6 can go into 36 6 times. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So now we need to identify from this list which numbers are prime. Okay, so we know 36 is not prime because it has more factors than 1 on itself, so it can't be 36. It can't be 18 because 3 can go into 18, 6 can go into 18, and 9 can go into 18. So it can't be 36. It can't be 36. It can't be 18. It can't be 12. It can't be 9 because 3 and 3 can go into 9. 3 and 9 can go in there, and 1 can go in there also. Can't be 6. Can't be 4. We won't use 1 because 1 is universal to all the things that we'll do. And the ones that we're left with now are 2 and 3. What are the factors of 2 and 3? 1 and 2. What are the factors of 3? 1 and 3. So in terms of being prime factors, these would be the prime factors of 36. Prime factors of 36 are 2 and 3. And that would be C, 47. Our answer is C. If we were to use a factor tree concept, we could break 36 into two factors, being 2 and 18. 2 is already prime. 18 could be broken into 2 and 9. 2 is already prime. We could break 9 into 3 and 3, and these are prime. So 2, 2, 3, 3. We would only need to list 1, 2, and 3. So we would still get our answer here. Our prime factors being 2 and 3, and our answer is C. We could also use prime factorization via the ladder approach, and using 2 can't go into 3, right back 3, 2 into 6 would go 3 times, and then we use 3 into 3, yes, 3 into 3, yes. What are the factors outside? Our factors would be 2 and 3. Okay, so 2 couldn't go into 3, right back the 3, 2 into this goes 3 times, 2 into 6 will go 3 times, 3 into 3, 1, 3 into 3, 1. So the factors, the prime factors that we use were 2 and 3. Number 48. Number 48 says, if 72 pencils were shared equally among 6 students, which would show, or which would give the number each student would receive? Right? What we're being asked here based on the responses is to identify the operation. Now, the key word in this is shared. Okay? In mathematics, once we are talking about share, we're going to be using the division sign. Okay? So what we need to do now is set this out, and we would say 72 divided by 6, which would give us 12. Now, do we see this 72 divided by 6 anywhere in the responses we have? We have that as B. So our answer is B. 72 shared for 6 students would be written like this. Number 49. How many 1/3 are there in 6 wholes? Now 6 whole things are shown here in the form of some circles divided roughly into thirds. So all I would need to do now is to count the total number of thirds in 6 things. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my answer for 49 would be 18. It's the same as saying what? 3, because each of them would be divided into 3, multiplied by 6, and we get 18. And that would be A. So number 49, our answer is A. (2016) multiplied by 9 we'd say 9 times 6 would be 54. Let's change our color. 4 carry 5. 9 times 1, 9, and 5 would make 14. Put down 4, carry 1. 9 times 0, 0. Carry back 1, and 9 twos, 18. So our answer for number 50 should be 18,144, which would be A. So our answer for number 50 is A.